Have you ever pondered the consequences if the Earth's core suddenly cooled off? It's a question that might seem outlandish at first, but it opens up a fascinating exploration of our planet's inner workings. Picture our Earth not as a solid, unchanging sphere, but as a complex, layered structure, each layer with its own unique properties and roles. The outermost layer, the one we live on, is the crust, a thin, brittle skin that covers the Earth. Then, beneath the crust, we find the mantle, a thick layer of hot, semi-solid rock that makes up the majority of our planet's volume. But it's deeper still where things get really interesting. Nestled beneath the mantle, we discover the outer core, a sea of molten iron and nickel. Dive even further and we reach the inner core, a solid ball of the same materials, heated to extreme temperatures by immense pressure and radioactive decay. The core's temperature is staggering. It ranges from 4,000 to 5,700 degrees Celsius. To put that into perspective, that's hotter than the surface of the sun. This fiery heart of our planet is a literal powerhouse, driving geological activity and generating Earth's protective magnetic field. The composition and temperature of the core hold the key to many of the Earth's most fundamental processes. It's the engine room, the beating heart, the fiery furnace that fuels Earth's dynamism. So, with this fiery furnace at our planet's heart, what could possibly happen if it suddenly cooled off? It's a tantalizing question, one that invites us to delve deeper into the mysteries of our planet. But be warned, the answers may be as unsettling as they are intriguing. Stay tuned as we explore this chilling scenario. To understand the potential consequences, we must first comprehend the core's role. The core of our planet is not just a fiery ball of molten rock and metal. No, it's much more than that. It's a dynamic powerhouse that plays critical roles in making Earth habitable. At the heart of our planet, two distinct regions make up the core: the outer core, a sea of molten iron and nickel, and the solid inner core, predominantly iron. The constant churning motion of this molten outer core, coupled with Earth's rotation, generates a phenomenon known as the dynamo effect. This effect creates Earth's magnetic field, a protective shield stretching thousands of miles into space. This magnetic field is often overlooked, but it's as essential to life as water and sunlight. It acts as a cosmic guardian, deflecting harmful solar radiation that can strip away our atmosphere and expose life to lethal doses of solar energy. Imagine a suit of armor protecting our blue planet from the harshness of space. In addition to creating a protective shield, the Earth's core also drives the engine of plate tectonics. The intense heat from the core creates convection currents in the mantle above. This movement of molten rock is what causes the Earth's crust, divided into several large plates, to move and interact. The resulting tectonic activity leads to earthquakes, volcanic eruptions, and the creation of mountain ranges. Let's also not forget the role of the core in volcanism. Volcanoes are essentially safety valves, releasing the Earth's internal heat and pressure. They contribute to the carbon cycle, playing a part in maintaining the delicate balance of life on our planet. So you see, the core is not merely the Earth's hot, heavy heart. It is a complex and vital part of our planet's systems, driving many of the processes that make Earth a unique haven for life. Now that we know the vital roles of our planet's core, we can start to imagine the catastrophic effects of its cooling. Imagine a world where the Earth's core has cooled. Such a seemingly unthinkable scenario would first rattle our planet with profound immediate effects. The core, a hotbed of ceaseless activity, and the furnace that drives plate tectonics would come to a standstill. The once constant movement of tectonic plates sliding over and under one another, creating earthquakes, mountain ranges, and deep ocean trenches, would halt. Volcanic activity, a byproduct of such tectonic motion, would dramatically decrease. It's easy to misconstrue this, a silver lining. No more eruptions, a safer world perhaps? Not quite. Volcanoes play a pivotal role in maintaining the Earth's climate. They release gases and particles that reflect sunlight back into space, acting as a natural thermostat. Without them, our world would be at the mercy of extreme changes in temperature, potentially rendering life untenable. But the cascading effects of a cooled core wouldn't end here. In the long run, we would face the possible termination of the Earth's magnetic field, a shield that protects us from the sun's harmful solar radiation. This invisible barrier, powered by the core's activity, could cease to exist if the core were to cool. This would leave us vulnerable to the onslaught of solar winds, which could strip away our atmosphere, much like the fate Mars met billions of years ago. The sun's rays wouldn't feel like a comforting warmth anymore, but a lethal radiation. No longer would the sky be a sanctuary for birds, nor the surface of the earth a fertile ground for life. The oceans would evaporate under the severe radiation, leaving behind a desolate, lifeless world. Such is the chilling aftermath of the Earth's core cooling off. From the immediate of plate tectonics to the long-term disappearance of our magnetic field, the consequences would be catastrophic. The core, with its intense heat and ceaseless activity, is more than just our planet's heart. It's the lifeblood, the engine that fuels life on Earth. If it were to cool, our world as we know it would be altered irreversibly. So what's the conclusion of our frozen core tale? The Earth's core plays a vital role in maintaining the magnetic field and keeping plate tectonics in motion. Should the cool down, the magnetic field would fade into oblivion, leaving us vulnerable to the wrath of solar winds. Additionally, a decrease in the speed of plate tectonics would result in a static crust, impacting both volcanic activity and the reshaping of our landscape. But how does this affect us and all life residing on Earth? The absence of the magnetic field would render the surface uninhabitable due to the harmful solar radiation. A lack of volcanic activity would disrupt the carbon, affecting all life forms. This scenario serves as a startling reminder of our reliance on the intricate and interconnected nature of Earth systems. If you liked the video, please remember to like and subscribe.